Hello everyone. Thank you very much, Professor Davidovits and Ralph, for inviting us. And it's a real pleasure each year to be here, to present here. This time we have a little bit more time for presenting. And I would like to go back to year 2015, first of all, when we first came to the Geopolymer Camp. And we met Alex and we met everyone. And we were in alkali activated material at that time. We had been working on it about 7 years, on alkali activated slag mainly. And we had all these problems of instability, of efflorescence, and unpredictable results. And we couldn't understand why this happens. And we came across geopolymers, and we came here to study. And we were asking all these stupid questions to professor, like why is it not the same, like alkali activated materials and geopolymer should be the same, because in both cases we use alkalis, in both cases we use slag. And he was just smiling and like saying, okay, try. And after several years of trying, finally we got this like, that's what he meant. That's what's written in the book. And I wish you all, when you work on your geopolymers, and to have these moments when you realize what you really read in the book, what was really happening here in the Geopolymer Camp, you will find it all from practice for sure. So what we want to talk is the process of going from lab to industry, so the process of growing up in production of geopolymers. And the first, it should come. Yeah, it's going there. Okay. So we made this video to teach people the process of correct mixing procedure when we make the binder first, then we add aggregates, how much should we mix, what is the procedure to avoid mistakes. Because when you tell people that you need to make your binder first, still some people will mix everything together. And so you need to show exactly what you mean. And when we work in the lab, we have very small dosages of materials, so we can be very precise. We weight all the materials in grams. We follow the procedure strictly. We get perfect results, I would say ideal results, sometimes with super high strengths, with everything. And it's easy because you can bring materials, I don't know, from the moon, from another part of the planet. It's not, the cost is not an issue in this time. So you can watch this video in YouTube, it's available, if you would like to. And also with 3D printing, it's a picture from Geopolymer Institute. When you work with the laboratory, you don't face problems of the equipment. So you only test your material for 3D printability most of the time. And you don't have to bother of the pump, of the cleaning of the tubes, of the speed of the extruder that's going, and all these issues you will face later when you go bigger. And in 2016, we had, all three? Yeah, in 2016, we had our first tests of 3D printing geopolymer, and everything was done manually, so the guys have broken their backs, and of course, the material were brought by plane. The materials were very precisely dosed. We had a very perfect composition of our recipe, and the results, of course, were amazing. We got, with some recipes, 80 MPa, with some recipes, 50 MPa, but it was much more than enough. And we had a success from the first attempt. Yeah. So, but after guys have had problems with their back, we advanced to a better mixer with the support, you know. But still, the dosing is manual, so you can bring materials from far away. The cost is not a big issue, though you have to buy some of the materials. And, but it's very dependent on the person who is mixing. So you have to have very good educated engineers for dosing the material, for mixing the material, because we had an issue when we tried to teach the 3D printer guys how to mix geopolymer. Each batch was different. The recipe was the same. Everything was the same. We were watching them, but each time something was different because they didn't clean the mixer one time. Another time there was, I don't know, some material left in the bucket. Another time they thought, oh, why should we do so precisely? Let's just put, I don't know, a little bit more of water, of whatever. So one time you get 30 minutes of setting time, another time you have 1 hour and a half setting time, and for 3D printing it's crucial, it's very critical. So each batch will be unique depending on the person who is mixing it. Yeah? And so, as I said, you can bring very expensive materials for this small-scale pilot project. We brought them by plane to Irkutsk from another part of Russia, and I know we can send to Italy, Alex can send to us, and the cost of final recipe can be up to 10 euro per kilo, which is not scalable at all, if we're talking about construction. And for 3D printing small projects, you don't think that it's all automatic right now. You press a button and the printer does its job. No, it's about 10 engineers running around, fixing all the parts of machines, fixing the mix. And for now, it's the small, kind of small-scale 3D printing projects really kind of testing. So, but when you go bigger, we go to medium-sized projects. So this is a project we had recently near Moscow. We made a geopolymer bridge. And here, it's another issue. You are dealing not with engineers anymore at the construction site. You are dealing with ordinary workers, not so skilled, not so educated. So you have to prepare all your materials at your job site in advance. You have to dose them. So what we do, we have a bag, precisely weighed. We have a precise weight of reagent that you put to this bag. We have a precisely weighed aggregates. So it's the only way you can try to avoid mistakes at the job sites, because here people will weigh the material, you see the mixer, they will weigh the material not in grams, but in buckets and the amount of buckets and spades that they throw in this mixer. So to avoid mistakes as much as possible, you have to do everything in advance. So here, the high-tech should be as minimum as possible. You should do all your high-tech before. Yeah, and so the equipment is really basic. Of course, the preciseness of these recipes is much less, but we don't need extra high super performance concrete here. The task was to get C50, so we get this C50 easily with geopolymer, because geopolymer can afford much more strength. And we try to make it a little bit, let's say, more to make this kind of gap, because we knew that there will be some mistakes and fluctuations on the job site. It's unavoidable when you deal with people. So this is how we now supply the material. It should be precisely weighed and dosed in advance. So we need equipment to produce geopolymer right now. For small geopolymer cement production, you need not a very big mixer, but still it is equipment, so you need to put investment. You cannot make it anymore by hand. It's not laboratory anymore. And you also bring materials already not in small bags, I don't know. You have to pay for your materials, you have to deliver them, so you have to really look for the source of material closer to you, cheaper to you, so you have less choice, and you have to work with what you have, with what you can get cheaper. You still don't buy it full trucks, so the cost for you will be much higher than for bigger production, and we will talk about costs a little more. And also, to prepare your reagent, there is an issue. Okay, in Europe you have Wellners who can deliver you a ready-made geoseal, but when you don't have them, you have to prepare your reagent with the mole ratio you want yourself. So you take what you have available at the market, the soluble silicate, and you need to have a storage, you need to have a production site to produce your reagent. And now we go to the most important, the cost of raw materials. It's a good example that we have with fly ash. For example, fly ash, when you buy it like 1 ton, the fly ash itself costs 2 euros per ton at the factory, at the power plant. So it's nothing, it's very cheap. Then you cannot buy it in a truck. You need a big bag, for example, 1 ton. So the factory itself, the power plant, doesn't sell in big bags. They are not working with that. So there is a partner who is handling fly ash. This partner needs to earn money. He needs to transport fly ash from the power plant to his site. He needs to process it, to put it into big bag. So we add the price of big bag. And this is a green part, which adds with a profit with the packing and handling, then delivery to their site, and then a small profit of this partner who is making this handling. And then we need to deliver this fly ash from this partner who is handling fly ash to our side. And this is the biggest cost. It costs like more than 700 euros because nobody will just go with 1 ton and there is a full truck that has to go with 1 ton and it will cost like a full truck, and the full truck costs 700 euros. So your 1 ton of fly ash turns from 2 euros to more than 700 euros if you buy only 1 ton. So if you need 10 tons, it gets a little bit lower because you divide the same cost to the 10 tons, but still you need a handling partner who will make it all in big bags, etc., etc. And you only start getting some economy when you start buying into 20 tons full trucks without big bags, so it's bulk. But to buy bulk, you need your own silo storage. You need to have a bigger production site on your own. So, and then the cost becomes more or less reasonable, but still it's not 2 euros, because when people start calculating the recipes, usually they, okay, fly ash costs 2 euro, oh, it's nothing, let's use fly ash. But then you need to calculate how much it will cost at your site. And can you receive it in bulk or not? So make all these calculations. And when we go really industrial, so you need to have silo storages. You need to have a big investment into your production site. And here you reduce operational costs on your products, on transportation, on all your raw materials, but you need to have an investment. And the first thing you need to think about when you're thinking about making a geopolymer production plant is where should I place it? For example, in Russia, we have this situation. We have resources in the eastern part, most of the raw materials are there, but the clients are in Moscow and St. Petersburg, which is 2,000 kilometers away. So it's up to us to calculate where should we make it. Near resources, which are, the transportation of resources will be cheap to us, or the transportation of the ready good to the client will be cheap for us. So this is something that you need to calculate on your own, depending on where you are. And yeah, for industrial scale, you need to have a real dry mixing plant, but still the investment is not comparable to Portland cement production, for example, where you need 200 million euros for one plant minimum. Here we need 20 times less investment. We just need a dry mixing plant, and we don't need to have kilns or burn gas and whatever. So, but there are limitations that come from the big scale now. When you have a laboratory, you can make, I don't know, 50 grams of 3D printing mortar, then you can make 50 grams of repair mortar, then you can make 50 grams of construction geopolymer according to request. But the bigger you go, the bigger is the minimum batch that you can produce. You cannot produce with a big mix of 5 kilos. You need to produce several tons, several tenths of tons. And so you need to have orders for this kind of products. So the range of products you can produce go down, but the amount you produce of one product goes up. Of course, all this reduces the final cost of the product when you go, the bigger you go, but there are certain limits. So if you have questions about economy, you can ask me, but I will switch now to more technical side to Andrey.
Okay, let me speak now a little bit more about industrial application of geopolymer concrete and products on its base that we have done. One of the products that we have realized, and it's a humid earth blocks and pavement tiles. This is products without a high amount of binder part. It's a humid earth consistency, and we have one product is going on right now, and developing and adapting the geopolymer cement to produce these construction blocks. These blocks are more resistant to aggressive substances and corrosive media, And it is also possible to make these blocks oil and water repellent. Taking into account this, this kind of products must be cheap. We offer a solution that, for example, for pavement self-blocking tiles, where only the top layer of these tiles could be made of geopolymer, and the rest is the cheapest based on ordinary Portland cement. So this allows us to save cost and give the final product some unprecedented properties. The other material that could be used with geopolymer is hemp. It's a very interesting material, especially when it is combined with geopolymer cement, and like humidors blocks, it's pressed and formed into panels or blocks. And this material doesn't burn, and it can have flexural strength more than 100 MPa, and it's doesn't ignite, so it and also could be a thermal insulating material for structural structural properties. And this is a challenge that Renca is taking apart and developing sustainable solution for waste utilization, and we are the part of National Geographic Innovation Challenge, the Ocean of Plastic. So beside hemp, there are many type of recycled and waste material could be used in geopolymer because they are encapsulated inside the structure and they completely mineralized. Roof covering is with geopolymer is also one of the unique solution. It is possible not only make the whole tile out of geopolymer, but apply geopolymer spray on the existing roofs. And we have tested, and it is the temperature on the surface of this type of covered roof was 8 degrees lower than the temperature on the roof without the coverage. So 8 degrees, each degree is equivalent to about 5% of energy. And in total, you can save up to 40% of energy for cooling the house during the summer period. So this is another example of industrial application, which Marina told you. And this is a final made bridge pedestrian. And this guy liked geopolymer concrete so much, so they asked more, but in different colors. So we offered them red. As Joseph told yesterday, red is beautiful. We say red is a new green, and we try to be in line with this fashion. Okay, so let's talk about construction 3D printing with geopolymer. It all started in 2015. Like today, we listen Shima's presentation about moon and say, haha, it's moon. And then it was like something like this in 2015. Geopolymer could be applied for 3D printing, haha. And at the end of 2015, we've been contacted by Nikita from Apiscore company, and he asked us to develop mortar for his 3D printer. And we have done it, and in January 2016, with Alex, we went to Irkutsk, to Siberia, near the Lake Baikal. And it was like minus 40 degrees outside and plus 15 inside. And we tested there 3 different recipes, the black, beige, and gray one. If you are not familiar with Apiscore company, this is a company who originally from Irkutsk, from Russia. They 3D printed a house in 24 hours, and they claim that it cost as many as $10,000 United States dollars. And this is a house built near Moscow in winter. And now they have moved to United States in Boston, and they have taken a part in the NASA's 3D printed habitat competition. Unfortunately, now they are not selling and producing 3D printers, and they're mostly concerned about R&D, and we had to go our own way with 3D printing. So in Irkutsk in 2015, there was a first idea of need of automatic mixing system for geopolymer concrete came. And 2017, we've been invited by the government of Dubai to take part in Dubai Future Accelerators. It's sponsored by the government, accelerator for innovative companies. And Dubai is very keen in construction 3D printing and has a government program that 25% of each building by 2030 must be 3D printed. So at the end of the program, you're laughing, but it is. In 2019, 2% of the building you will not get a construction permit if you don't have 2% of 3D printed parts in your building in 2019. 2020, it will increase. And by 2030, you will not get a construction. You cannot build a house with 25% of plastic handles. You have to have something structural, so that will force you to implement 3D printed elements in the building. So at the end of this program, we signed an MOU with Dubai municipality towards developing green geopolymer mortar for construction 3D printing, but using only local materials. And this is a vision of Dubai government that has been presented in the Museum of the Future in 2017, how this will be built in 2050. So it's like going to the moon and launching there this kind of module, and then in a couple of weeks you come back and you see this. The robots and drones are absolutely happy living their own life. They don't need you. In 2018, we were contacted by Gazprom Neft company, who wanted to implement 3D printing in their innovative storage facility in far north in Khanty-Mansiysk. And we have built a part of foundation with Geopolymer Concrete, so we don't have much time, so you can scan QR code and watch it on YouTube, the whole video about this process. I will skip it. And in late 2018, we've participated in Maker Fair in Moscow, and with a trial towards a project with Italian professor and designer Giuseppe Falacara. And there was a project of Llama Rossa, red flame. Again, red is very fashionable. And we were 3D printing, making trials of the sculpture that represent the red flame. And now we are in a collaboration with Polytech University in St. Petersburg, helping them in their 3D printing programs and trying to promote genuine geopolymer technology among students and professors, because there are a big mess about terms, about sources of information, about alkali, about activation using wrong misunderstanding. And we have developed geopolymer 3D printing mortar. And for this portal-based gantry type 3D printer. Yeah, and this is a kind of video. Together with the students, we not only study the recipes, but they have the equipment to study different shapes, its behavior, and construction properties of 3D printing objects made with geopolymer. And it is very small structure here in the video, and it was done in like 10 minutes or 15 minutes, but it showed that the mortar can hold half of meter height. And you can see the samples here on the desk, so you can touch and see that the geopolymer mortar has this advantages that it doesn't have any cold joint in between the layers, because with the Portland cement, cold joint is quite a problem. But with geopolymer, it has very good adhesion, and you can stop, go for a break, or stop for a night and continue the next day, and in the end, you will have no joints. So how do we work? We do study the local available raw materials, starting from the mineralogy and chemistry, we take samples from local materials, develop new recipes, do testings. As a professor explained it before, put it in the water, and at the end, when we get the perfect result, we go deeper and do tests of freeze those cycles, resistance to acid media, and so on. So at the right corner at the bottom, you see the test of acid resistance for geopolymer concrete. And before that, we didn't know that. We haven't had a standard, so we use 10% of sulfuric acid solution. Now we will use for sure 5% solution, so we can compare the result among the other researchers. So developing the standards is very important, because it allows us to compare what we have done in our lab, what you have done here, and so on and so on. And of course, if client needs, we do verification in the external lab. So we have done such tests in Dubai Central Laboratory in order to show the properties of geopolymer mortar for 3D printing based with their material. And we produce geopolymer cements and geosilicates. One of the main products is repair mortars. It's ready products, can be used to apply to airport tracks because it's fast hardening, and road repair, wall repair. Of course, 3D printing mortars for different type of temperatures, for winter, for summer, because it's very dependent on this. And with the cooperation of our Italian partners, we can offer a full line of equipment for geopolymer cement production. Alex will tell you more about the small-scale laboratory mixers, medium-scale, big-scale. And I will show you the scheme that is possible integration of geopolymer binder or cement mix unit into the existing concrete plant when you go a real scale. So it will prepare, dose, and correct mix the geopolymer cement, and when it's ready, it will discharge it into the existed mixer, and it will be mixed with aggregates, conventional way to prepare geopolymer concrete. This solution allows to save a lot of costs on the full-size concrete plant and make geopolymer concrete along with OPC at the same equipment. So especially if you have already silos or mixers for OPC production. And we have been working almost with every type of existing 3D printers and know exactly what to do to achieve the best results, and what type of mixer, what type of pump to use. So we do consulting on the equipment that you need for construction, 3D printing, pumps, and so on. And so we want to be a all-in-one partner, all-in-one solution, starting from geopolymer cement production, concrete mixing, and construction 3D printing. So we already have some international sales, and we are happy today that we put some Curacao here, and one of the representatives is here from. And these are our clients and partners. It's Geopolymer Institute, Geomeets, ABB for robotic arms, ArcelorMittal, we've done some project for them. And this long word called Main Matsapei. It's a mining company from Curacao. Okay, so that's it for presentation. If you want to contact us, you can write an email. We reply you for sure. And I saved some time to show you some recent, I would say, development in the world of geopolymer concrete. I don't know if you know, in Australia recently, in Sydney, Wagner's, they made a part of the road, public road, to the airport. So this is a video how they made it with geopolymer concrete. And now you can go to Australia and see, and this is a world first roadway made for geopolymer concrete. It's short, but it's on the public road. So there are researchers from Sydney and CRC, for Low Carbon Living Institution, will then use the result from that trial. They install some sensors inside, and they will use the result from this trial to create the first set of industry guidelines for geopolymer concrete. Yeah, so you can go through the link. And this video, I liked this researcher from Swiss Institute, EMPA. They have carried out the test on OPC, on resistance to heat. And here you can see what happening with ordinary Portland cement-based concrete when it's heated. When water, which is on molecular level inside the structure, started to boil at 600 degrees C, and it just kind of, I don't see any, can I? So they prepared the sample and covered, put it on some heater at 600 degrees, and started to heat it up.
kill the clock.
It's like a weapon. Yeah, it's really impressive results.
So we also try to spread our knowledge of geopolymer among young people, and this is our daughter presenting at the conference for natural science, school conference about geopolymer, and we hope that she was here the previous year and the year before, and I hope that she will also follow our tradition of making geopolymers in the future. And a Geopolymer Institute and Professor Davidovich has sponsored us in our crazy adventure 2 years ago when we went to the Mongol Rally. It's a charity rally devoted to saving rainforests. So you have to go on a really small car with a low engine, below 1.2 liters. And you have to go from London to Mongolia any way you want. So this was our route. We didn't only go to Mongolia, but we went from our city, Chelyabinsk, which is in the middle, in the center of the world. And we went all the way to here, to Geopolymer Camp. And after Geopolymer Camp, we started our rally from London and Mongolia. And yeah, it was, we crossed several continents. We crossed the border more than 16 times. And it took us more than 2 months and 30,000 kilometers. But a lot of impressions, meeting with people, and the main thing that you learn is that all people are very good and nice in the world. There are no bad people in the world. Everybody is very helpful. And of course, we couldn't stop making geopolymers, and we made the highest geopolymer in the world at 4,655 meters to repair the sign in Tajikistan on Pamir Highway. And we repaired the statue of Genghis Khan in Mongolia, the biggest horse statue in the world, because it's a shame, but the glue, the tile adhesive is not very good in Mongolia, so we had to repair it with geopolymer. So thank you.